What's up, everyone? Welcome back. Patrick here. Moving on to the next example. So if we're given this function f of x equals ln of 2x minus 3 over x minus 4, we got to find two things: the domain of this function, and then we have to find the inverse of this function. So this one's going to be kind of intense. Now, just in general, whenever we have ln of something, let's call it a, right? This could be a variable, it could be an expression. We know that that something, that expression has to be greater than 0, always, right? We know ln of x, it looks like this, right? All the x values have to be greater than 0. And so whatever is in this bracket of a ln function, that has to be greater than 0, whether it's a single variable like this or an entire expression like this here. So to find the domain of this function, basically what we have to do is figure out when is 2x minus 3 over x minus 4 going to be greater than 0. Not greater than or equal to 0, greater than 0, because you can't ln 0. And then this 5 here, it has no effect on the domain, right? This 5, this constant, as long as this value here is going to be defined, we're just going to be multiplying that value by 5, right? So it's really this that we got to figure out. When is 2x minus 3 over x minus 4 greater than 0? Now, if we were just looking at 2x minus 3 over x minus 4 by itself, figuring out the domain of just that function, that would be way easier because we just know x can't be 4. There's a vertical asymptote there. So the domain in that case would be from negative infinity to 4, and then from 4 to positive infinity, not inclusive of those 4s. But the fact that we have to figure out when is it greater than 0 makes things a little bit more intense. So what I'm going to do is I'm actually going to graph this. If you remember, a linear over a linear function, the vertical asymptote is at 4. The horizontal asymptote, what happens as x approaches positive and negative infinity? Well, it's going to be the ratio of the leading coefficients, right? 2 over 1. And then we can also find the y-intercept. So we could plug in 0 for x. We'd end up with negative 3 over negative 4, which is positive 3 over 4, which would be over here. And then the x-intercept, when does the numerator equal 0? When does 2x minus 3 equal 0? When x is 3 over 2, which would be over here. And so just from all of that information, we can tell that this function, it's going to look like this. A linear function always has this kind of opposite shape, right? Or maybe here and here. And just depending on those 4 characteristics, that shape pretty much moves and gets reflected depending on the values that you're working with, right? But this function in particular, it looks like this. And so now what we got to do is figure out when is this function greater than 0. Another way to think about it graphically is basically when is this function above the x-axis? When is it positive? Well, notice it's going to be positive here the whole time, right? Because this is going to continue going on forever. It's never going to pass that horizontal asymptote at 2. But on this side here, it's positive for this portion. And then from here, it's going to be 0 and then negative, right? And remember, this here is 3 over 2, the x-intercept, basically when the numerator is equal to 0. And so this function is going to be positive. This is going to be the answer for the domain, so I'm actually going to write it over here. So the domain is XCR. X has to be less than 3 over 2, not equal to 3, not less than or equal to 3 over 2, less than 3 over 2, because it can't equal 0. Remember, you can't have 0 in this bracket here. So x has to be less than 3 over 2, or x has to be greater than 4 for this portion here. Can't equal 4 because there's a vertical asymptote there. Function would be undefined there. So x is either less than 3 over 2 or greater than 4. that is the domain of that function, right? So it's a little more restrictive, a little bit more complex versus if we just had that to work with. The fact that there's this ln here, we got to figure out when is this function greater than zero above the x-axis. Another way to write this domain would be x is an element from -infinity to 3/2, not inclusive of 3/2, or from 4 to positive infinity, right? If this ln wasn't there, then this would be a 4 here, -infinity to 4, 4 to positive infinity, but because there's that ln there, it's only up to 3/2 for this portion, and then from 4 to positive infinity, right? So that there is the answer for number 1. That's the domain. Now what we got to do, we got to find the inverse of this function. So to find the inverse, what I'm going to do is I'm going to rewrite the f of x as y. So y equals 5 ln of 2x minus 3 over x minus 4. So I've done inverses in the lecture videos of a rational function. We got 2x minus 3 over x minus 4 if you want to go review that, but there's this ln here, so it's going to make things a little bit more complex, but it's actually not too bad. It's going to be very similar. We just have to do a step before that to get rid of this ln. We've got to put it on this side. So first thing we do with an inverse, interchange the x and y. So x equals 5 ln of 2y minus 3 over y minus 4. And then what I'm going to do, divide both sides by 5. So x over 5 equals ln of 2y minus 3 over y minus 4. Now to bring this ln over, basically if I got something like this, ln of an expression equals another expression, and I want to get this isolated, this b isolated, it's just going to be e to the power of a. Right? So both of these are the same thing. You could go from here to here, or from here to there. And so I'm going to apply this rule, and I'm going to go from here, where a is this whole expression, and then b is this whole expression. So basically this expression is going to be e to the power of x over 5, or e to the power of 1 over 5x. Same thing, right? We could have wrote this like that too. I'm just going to keep it as x over 5. I feel like it looks nicer. All right, so from now, from here rather, what we got to do is isolate for that y. And now that same process that I went over in the lecture videos when we have just a function like this, same thing, we're going to have to cross multiply and isolate for that y. So y minus 4 times this, if I continue up here, we'll have e to the power of x over 5 times y minus 4 equals 1 times this, so it's going to be 2y minus 3 here. And then we'll have e to the power of x over 5 times y minus 4 e to the power of x over 5 equals 2y minus 3. Let me just make sure everything's all good. Yeah, it looks all good to me. So now what we do is we bring all the expressions that have a y to one side, all the other expressions to the other side. So I'm going to bring this 2y over, then this expression I'm going to bring over there. So we'll have 4e to the power of x over 5 minus 3, e to the power of x over 5y minus 2y. Right, so just kind of interchange everything. And then from here, notice I could factor out a y from both of these. And now it's easy to get that y by itself. We just have to divide both sides by that bracket, and then that's going to cancel out there. Okay, so I'm going to write the final answer here. So the inverse would end up being this 4e to the power of x over 5 minus 3, it's not in the exponent, it's a separate expression, over e to the power of x over 5 minus 2, like that. Another way this could be written, got to be careful of this in multiple choice, maybe they'll give different formats. We could factor out a negative from the numerator and from the denominator, the negatives would cancel out, and we would end up with 3 minus 4 e to the x over 5. Basically, all the signs would change, right? So that's another potential. So you got to be careful. Like this and this are the exact same thing, right? So you might get this on the test, and then you might see this as the answer, and just looking at it, you might not think they're the same thing, but they are the same thing. I just factored out a -1 from here, -1 from there, negatives canceled out. We end up with this. This and this are the exact same thing, right? So either way, this is the domain of that function, and then these two expressions, which are the same thing, are the inverse of that function.